Hi everybody. Let's take a look at our next question. It says, what are the condensed structures of the following compounds drawn as models? And then we have two compounds, as our question says, drawn as ball and stick models that we need to transform into condensed structures. We have a color code. It tells us that the black balls are carbon, white are hydrogen, red are oxygen, and green are chlorine. So let's look at number 1. And to decide how best to write this as a condensed structure, I like to first sketch out, let's see how these are actually grouped together to see how to write it most efficiently as a condensed structure. Recall that in condensed structures, no bonds are shown, and we write carbon-hydrogen groups together with parentheses if they're repeating units, and substituents are indicated with parentheses next to, like to the right of whatever group they're bonded to. So first, let's just get an idea of how these things are together. So our first model, we see kind of a main chain with 1, 2, 3, 4, 5 carbons right off the bat, and a chlorine on the end. Sometimes it can be a little tricky to tell, is something a substituent or part of the chain? We're rendering a 3D structure on a 2D shape. In this case, we have a CH3 substituent. But in this case, it's kind of set, it looks like it's right behind the second carbon in the chain, so it's a little easier in this case to see it's a substituent. Sometimes it can get really tricky with longer chains. But then you should always notice that there's 3 hydrogens on this carbon there. If it were part of the chain, you would only see 2 hydrogens. So that should tell you as well. So we have this main chain that I'll highlight in blue. And then we have this substituent, put a little red dot there, that's going behind the chain, a methyl group there. So I'm going to draw it as, I'll write CH3, and then we've got a bond to a CH subunit. And then I'll draw a little line going up to the CH3. Obviously, this isn't the condensed structure because I don't indicate bonds or arrange them above or below each other in space. But this is to help me compose the most tidiest condensed structure. And then I have CH2, CH2, so 2 of those. And then finally I have a CH2, Cl there at the end. So to write it as a proper condensed structure, I want everything all in one line. Now I actually have 2 ways I could write this. I could write it as CH3, my first group in the chain, and then I could write CH and in parentheses CH3 to indicate that methyl group substituent on carbon 2. But this gets a little confusing because next I have 2 CH2 units, which I'd want to put as CH2 in parentheses and then a 2 subscript indicating as 2 repeating units. That looks a little bit confusing, untidy next to the parentheses. So let me cross that out and write this maybe in a little more clearer way. So looking at the end of the chain, I have the end of the chain and then a methyl group on the second carbon. So I can actually write that as, in parentheses, CH3 subscript 2. So like 2 methyl groups stuck on the end of the chain. That separates it from my second set of parentheses a little bit and makes it a little easier to read. So the 2 methyl groups and then the CH group. Now I have 2 repeating CH2 units. So in parentheses, I write CH2 subscript 2. Now, why don't I include the last CH2? Because there's one more CH2 on there with a Cl. Why wouldn't I include that in the parentheses there? Well, because this one has a bond to a chlorine as well, not another carbon. So I don't want to create any confusion as to where my chlorine is bonded. Otherwise, I might think it was on one of the other carbons there. So this one I have to write out separately, CH2Cl. So that's the answer for number 1. Now let's look at number 2. So I have now my main chain, which is 1, 2, 3, 4 carbons. And then there's an oxygen it's an ether, and then another carbon. And then in terms of substituents, I have a double bond to an oxygen, and then I have one little methyl group sticking off. Well, it wouldn't be carbon 2 if I'm numbering in the proper IUPAC order. It would be the second to last carbon in the chain, but a little methyl group substituent off of that. So let's write out my sort of bonds, and then we'll put it in a condensed structure format. So from left to right, I have CH3, and then CH, and then I'll draw a line up to the methyl group coming off that second carbon. Then I have a CH2. Then I have my carbonyl group. So I draw C, and then I'll put a double bond going up to the oxygen. Well, and I can put bonds here to, this isn't an official structure, so I can put bonds there. I'll put little bonds in between each of those main chain groups. And then linked to the carbonyl carbon, I have an oxygen. And linked to that, I have a methyl group, CH3. So now let's put this all in one line in a condensed structure format. So here I don't have any confusing middle parentheses, so I'll go ahead and write it as CH3, and then CH, and then in parentheses, CH3, indicating a methyl group off of that second carbon. Then we'll write CH2. Now my carbonyl carbon, and then the next carbon is our carbonyl carbon, which has a double bond to an oxygen and a single bond to an oxygen. So again, we don't show bonds in condensed structures. We'll just write C, and then we actually write O2, showing there's two oxygens, and then CH3. So that's our condensed structure. For number 1, we have CH3 in parentheses, subscript 2, CH, and then in parentheses, CH2, subscript 2, CH2Cl, and then for molecule number 2, CH3, CH, then in parentheses, CH3, CH2, CO2, CH3. So there we go, all in one line, no bonds, and parentheses indicating our substituents. See you on the next video.